So here what I want to discuss is, look, everything is straight. Okay, so I want you to, like, if you come up here, so here you can see in the copy instance, it's a Houdini side effects page where you get the help on attributes and stuff. So have a look at it. It's copy instance, copying instance, and over here there are a bunch of attributes. These all are inbuilt attributes, and which you can apply on copy stamp node. Okay, so we're going to use most of the attributes in this project. I want to talk about pScale. So pScale is particle scale or point scale. It is a uniform scale. First of all, it's a uniform scale. So uniform scale, I hope you know that. So uniform scale is, this is uniform scale. It's like there's no it's just uniformly scaling. It's not like on left side or right side. So left side and right side, it's called scale, and uniform scale is this one. Okay, so even there is a scale attribute. If you come up here, you can see this is scale attribute, and pScale attribute. And scale is non-uniform, which means it has 3 vector, x, y, z. You can control your x size scale in the x-axis, scale in the y, or scale in the z. And pScale is the float. There's only one it's a one float or one vector kind of. Okay, so we're going to use pScale, and I'll show you what happens. So I'll come here and attribute create. Okay, and I'll watch from here. So your spelling has to be perfectly right. It's like you have to go here, you see everything is small letter, so you have to type that small letter as well. So like as you click, it's like everything's disappeared. Why? Let's see. The class is point, of course. It's a particle scale, so always on the class of points. And float, we know that it is float from here, because scale will have you know 1.2, 1.3, the decimals, so float. And ignore all these, says, and the value is 0. That is why. So that is why it went to 0, because the value is 0. So if I keep it 1, then boom, now every scale has 1. Awesome, isn't it? So same way, now it's like it's very uniform, right? Of course, if you can bring any attribute here, but we don't have any attributes. So what we do is, first of all, our goal is to get a random particle scale, isn't it? It should be random. Like right now everything is really straight. Okay, so of course we know that in the attribute there is attribute randomize. Okay, so we need to randomize. So there is an attribute called randomize. So I'll cancel this. Instead of this attribute create, I will plug in attribute randomize, because in here in the random, we now have minimum value and maximum value, which means we can give a range. So let's write. So as a default, it has put me to CD, but we will change to scale. Okay, so right now you can see, like, as we type in everything, random uniform scale happening based on 0 and 1. So now we know that, okay, that it's working. So let's type in 0.5. Yeah, it is working as well. Okay, then we need to set a minimum value, right? This is like taking 0. 0 means nothing. It's like plain, nothing. But we want every point to have some kind of point. So keep it 1. Okay, so now more has generated, because before there were few which were taking 0. So it's like this. And now we know, okay, we can, let me see. So okay, we can do this, is working, but the angle is different. Like, first of all, it's very big, and secondly it is staying up. the vector, or the where this normal is facing is up, or up vector, the other word. That's a technical term, up vector, but it is all standing. That's what I'm trying to say. So we know that we will adjust a few more, maybe 3. So I think 3 is also too much, and we got 2, and I go 0.8 or something. Okay, so now it's much better, or maybe 9, 0.9. Okay, much better. So let's go here and see, okay, what is the other. So I think we can do scale, because it's 3 vector, right? It's 3 vector. We can give thickness to each one randomly. So I'll type in here pScale so that I know what is happening, because we're gonna bring bunch of attribute randomize node which has everything random. The color is random, the size, I think the size is perfectly same, so we're not going to use scale. So because everything has same tube, I guess. Yeah, everything is tube, but only thing I can see is there's a curve happening. You can see here, even here it's curve happening. So next what we want to do is, if you again come here, you can see the rotation is the problem. So yes, so we read it, and the additional rotation applied after orientation attribute. So after orientation, so what is orient? Oh, it's here, orient. Orient is a float 4. Okay, it's a 4. And orientation of a copy. So orientation means rotation, basically, in the directional base. Okay, directional base is orientation. Rotation is it's the same, but this is more based on the world of 3D world. Okay, so let's bring attribute random, because we need random. We need random rotation, so, or other word, orientation. So orient, spelling has to be correct. Double check. Yes, and it's a float. It's a point, and it's a float. Of course it's going to be float. You don't have to set float, because you give the value float, I guess. So dimension is 4. Oh, so the moment I did that, it all started to fall on the surface. That's good. So we will keep it -1 and 1, because so that it goes both the direction, the negative side and the positive side. So we get little more distribution, isn't it? Nice, 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 nice. Okay, so next one what we saw here is rot. So rot will additional rotation. It's going to be we're going to get an additional rotation. So I'm going to take the same thing, because the rot is also float 4, and orientation is also float 4. I'll type in here rot, and I'll plug it in here. It's like it said here after orientation attribute. Okay, so this is my orientation. So after orient, I'm doing the rotations. See the difference? No difference, because we did not write it. All right, so I think it gave you worse. It didn't like it. I did not like it. So you see, without the rotation, with the rotation, it's up to you which one you prefer. I prefer without the rot. Of course, what we are after is more likely giving just with the orientation. Okay, so let's see what else we can add up. Vector. So velocity, there's no velocity in our case, and scale we can try, and normal, there's no orient, you can use n. So that's what it says. You can see up also. So up vector of the copy is no orient. All right, so n and up works together, so I can show you that. So I put this 2 things aside, and I'll plug it, because I want to show you this method, which is more cooler. It's n and up, because if no orient, okay, so it doesn't need to have orient, but rod will works with orient. And yeah, let's see without further ado. So orient, it needs n, right? So n normal. So like normal has a condition that here there is a face, isn't it? So now he knows like where to face. So the normal is this side. All right, so what is normal is this side. If I plug it in, you can see, yeah, here. Okay, it's here, it's facing this side. Okay, but if I plug into the point, then it doesn't have a normal, because it doesn't have a face. Then how can it have a point? I mean, how can it have a direction? See, here you have it and here you don't. Okay, so which means normal has to be placed before scatter, or it has to be on the geo. So now you can say, okay, I want the point normal. All right, okay, because we're gonna play around with point normal, right? So here you can see this one. We're gonna do normal to the points. Like we are playing with the points, right? So it has to be on the point, because scatter has points. I mean, now scatter has normal, because previously it has the point attribute, there is normal. So now scatter also has a normal. So if you notice, this is the normal where the points are facing. So they are all facing up. Okay, and of course you can randomize normal. If you put n, come on, my mouse has some trouble selecting and stuff. So so if I come here, you see I have a randomized normal. Okay, so but in our case, I don't think we need a randomized noise, but we keep it. Let's see how it's happened, how it's gonna be. And if you click here, next one is up. Up is up vector of, it's a plus y axis of a copy, and if no orient. So there's no orient. Of course, we don't have an orient. And we type in random and we say up. Up is a float and 3 vector. Now let's see. So now let's see. Okay, I plug it there and I click here. You see. So you see, this is how the normal, like when you apply just the normal and scatter the points on pScale. So this is how it looks. But when you have a up vector, then see, now it has an up vector. You see, it is distributed. Okay, because the up vector where it is facing up is like I can let me see if I can show you the up. Okay, let me see if I can show you the up. I'll click on the mask and up. Okay, yeah, see, this is how up is randomized. Okay, so this is how it randomized the look. And if you have randomized normal, then come on, then let's see what's going to happen. So if I uncheck it, problem with my mouse, sorry. So this was, right now it is all facing on the ground. Okay, but when you randomize, it's going to be up and down, but we don't need up. We know that what we are after is all are lying on the icing. So we don't need random normal, because we want what we are after. So now you can see, so we got distributed, but up vector we can give a negative value, the 3. So now we have more. I know this is very weird, so I'll just plug it in. So see, we have more distributed, isn't it? Like what we are after, kind of what we are after. See, but it's very small. Of course, it's small more than what I thought. Okay, so now we know that this method is not good. So I'll connect a switch node to show the difference between using of normal and up and just orient and rotation. Okay, so look at it. So here we have all the y vector is coming, it's facing up, so we don't prefer using that, but we need in what we are after is where we have everything light under on the surface. So I think this is far better than this method. Okay, but I just wanted to introduce you other nodes, other attributes which are very useful for for shaping your geometry or shaping your points. Okay, so I think we are good about that, but we need if you see here, it's a different randomized color, right? Very simple, pretty simple than anything else. So attribute randomize, boom, series on all there, already there, and you can see anything, because don't forget in the copy stamp node, in the attribute tab, as a default there is no, if you can see here, like there is no CD written. So these are the default value which gonna transfer from here. So it's like if you have here CD mask NP pScale up, but in the copy node it's not gonna get you anything, because as a default it's not gonna give you anything unless you check this box. So now if you click here, you get everything, every attribute from the points, whatever you have, it's going to be here. Okay, so now we have color also. We gonna view with the donut. Look at here. So this is what we are after, right? So we turn that into pink. I'll turn that icing to pink. Yeah, I believe that's good. So we will adjust the color in the end. All the adjustment will be happens in the end. I don't want to waste time on tweaking each and everything, because the setup is done. Like this, there's nothing to add. All you have to do is tweak everything. Just tweak it. So next goal is to make this thing a little curve, but before that I want to now we know that we can get this as well in a very easy method. So I'll just do that. I'll just optimize everything. So this is our node tree. Okay, here we have the base donut setup, and from there we have icing setup, and from the icing we have sprinkle setup, and that's one method. So this is sprinkle type 1 tube, and we have another we are going for is this nuts. So I'll just keep it here. From this same setup, we can actually get a nuts. So I will just drag and drop here. Okay, we're gonna change all of this, but for now just keep it. So we will optimize it, but I just want to show you quickly everything. I'll just take it from here. Okay, so same thing, sprinkle 2 I'll type in, and I'll change the color to maybe a little more dimmer. Sprinkle this one. So this is second sprinkle we are after. Okay, so same method. I'm gonna plug it here. In this type I will be using this one as well. Okay, so I'll just keep it as a side, the orient and rot, which we did not use in our tube type method, but it will be helpful in the nuts method. So I'll type in here 2 nuts. Okay, so for the nuts, we know that sphere is a good factor to do. So first we will take the geometry to replace it. I'll check that. Okay, so sphere, and then polygon, high frequency, of course, because we need to shape this up. So easy shape is mountain. You click there, mountain, boom, you have what you want, something like this, isn't it? So it's just a matter of, you know, a mountain, you got what you want. See, some kind of shape like that, but there are spikes, but don't worry, we can improve that by keeping more this and a little, you know, so something like this, or, you know, based on what you're after, something like this. I'll keep it for now. I'll keep that, and I'll delete the tube and I'll plug that in. Boom. So now, voila. But you can see there is some color matters happening. That's because in here we have normal, and in here we don't have a normal. So that's why. So if you bring a normal, it will fix everything, because now it has a normal, both has normal, so it fixed, right? So you see here, in this thing we need a really small scale, you know, something like this, and of course we need to change the mask. You know that how you get it, right? So it's just a matter of click, 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 try. Maybe because it is not there. Yeah, I knew it because I turned that all off, right? So that's why. Okay, so I have that where I wanted to spread. Okay, so I'll just change the mask by future from here, because here it's very tiny, but if you come here, it has everywhere. Okay, so that's why. And I will also bring it, not completely, yeah, it's going to take from there as well, but we don't need that. Yeah, okay, so yeah, just play around, get the shape you like. Okay, and of course it's all linked, so the point is too much for this. For now I'll keep it 700, but I know this is more than 700. But to get the shape what we are looking for, we need to make it very small, so that you know, see, it takes time, right? So up vector. Okay, up vector is gone. I'll just keep the mask vector. Okay, and off. Okay, so you see everything has same. So what we can, how can we improve this is by you come here, you can see the scale. So that's the only thing I think we are lacking of. See the scale, there's some are thin, some are fat, some are tall, all of that. So we can get that first, and before that we will just try the orient method also. So switch, save, switch. Let's see what's the difference between this method and, so I'm removing the color because this has only one color, there's no random color, so I'm deleting the random color. I'm just keeping that, and I'm seeing the difference. Of Of course, I'll change the lesser scatter so that it reads faster. 400. See, even 400 is taking time. 400. Yes, 400 is good. So I don't want this small size. That's too bad for what I'm after. Maybe 3. Yeah, 3 is good. And what you can see, what you can notice here is that same this one. So I'll bring a scale after, because here I need to look what's the difference, right? Like which one is good, this one or this one. We can play around and see. Don't worry about that. So after pScale, so why after pScale I want to plug? Because this is a method, right? So it's a method, and I don't want to just keep scale attribute for both. I'll just keep one attribute instead. So attribute random. Yeah, so here nothing is plugged, so I'll plug that method and this method as well. So as a default, of course, always go to the CD. So but I'll change to scale, and scale. So as you know, say change the scale, look at it, it has different shapes and size. That's because, so this is a 3 vector, the 3 float 3, so it is float 3. Okay, so minimum value I'll put for the y I want, sorry, minimum value won't be negative, because negative is, right, when it's scaling, it's gonna stretch it. So minimum value will be, it's gonna stretch inwardly. So minimum value of everything will be higher. Okay, so then it won't squeeze. Okay, I'll keep everything 5, I guess. I think I'll keep it everything 5, and it randomizes in between. Yeah, so in between value it's going to randomize. Much better, I guess. I believe it's much better. Yeah, so yeah, but let's see which one gives you better shape. The first one, let's see the first one. No, I didn't like the first one. I like this one far better. So I'll put a negative value here just to add here, here, and it's a 4 vector, so here as well. So give you some different, I believe it's a different, yeah, for me it looks different. Okay, so I'm going with this. Of course with a lot of scatter node, so I'll put maybe 1000. Let's see. Yes. So let's have a look with the not bad, right? Not bad. We need to do a little bit of tweaking, of course. Has to be done. And one thing that I note is, or one thing that I wanted to show you is one method of a node called pointrelax. So of course in the scatter node there is relax, but there is one point relax node itself called, yeah, it's this one, this one. But I want to explain in a different way. Then we continue this. So first I will just get a grid. I'll get a grid, and I'll avoid watching this. Okay, avoid watching that, and so I'll just come here. I'll delete this part, by the way. So I'll keep a copy stamp. Okay, so this is the point that I'm gonna generate something like this. Okay, and then I put a sphere, then I plug it in. Okay, you watch it. Of course, you need a random pScale, pScale with some value. So you see some values, and then if you point relax it, because it's gonna relax like this. But when you click this one to this one, boom, it's gonna what exactly it's doing is, if this is not there, so this is how it's going to be. This point relax will take the node and take the points. Okay, so it's like I'll bring a scatter to make it more understandable. Okay, so yeah, so that's correct. So I will put maybe 100 points, no, 200, then only it looks, you will understand what's happening. So you see here, it's all intersecting. It's all, most of them are intersecting. It is not moving left or right. So if you come here, it is not moving left or right. So whatever you are set here, it's doing that. So relax, of course, it just relax, try to relax, based on this. But like even here with this, it is trying to relax it, but still it's just, it is trying to attach, or it doesn't know like the pScale value of other. But if you put relax iteration based on the grid, so here you need to connect the surface and here the points. Okay, so now you see it trying its best to avoid intersecting. So see, the maximum will be like this. Okay, so that's because there's no point, like otherwise it has to squeeze by itself, then only it can place it. It's doing, the point relax is doing his best. So you come here, you can see it's taking half of it, but here you cannot see anyone taking half of it. It's trying to, it will try its best to stay away from other points based on pScale. So you see here pScale, so based on this attribute it is trying to iterate. So you see it trying to iterate its best. So see, so right now if you put the iteration is 100, then it tried its super best basically. So normal, this way. Okay, so yeah, so that's it. So I'm gonna, so if you notice this one, I'll example for point relax. Okay, and yeah, so here you can see it's gonna take some time, I guess. No, it didn't take that much time, but here I think the point relax will help a little bit to stay away from others. So I'm gonna, after the pScale, and this scale, it can be before, just after the pScale will be good. Point relax. Okay, so point relax, and of course point relax. So point relax didn't work completely unless and until you connect that to the surface. Yeah, see here you can see it's nobody's touching, it's everybody's doing social distancing at its max. Okay, so that's a good tool to teach. Okay, so I'll get back with all the modifications and so. So I'll be right back.